Hello, prepress professionals. Let's take a quick look at this proof here. We have a problem. We have some banding going on. In this episode, we're going to take a look at a common cause to this. It has to deal with processing files that are 16-bit versus 8-bit. Let's take a closer look at this. So what do we mean by bits? What are bits? Well, let's just talk a little bit of math. It won't be a lot. And when I say 8 bits, what does that mean? Well, you know that computers store zeros and ones. Well, that's 2 possibilities. So let's take that 2 possibilities and let's multiply it by itself 8 times. 3, 4, 5, 6, 7, 8. And we have this number, 256. You need to be comfortable with 256. It keeps showing up on computers all the time. So the way I'm going to notate this is 2 to the 8th power. That's equal to 256. 256 what? I'll get to that in a minute. Now, let's start over again. And this time, now let's do it 16 times. Once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've done it 16 times, and now we have a number 65,536. That's a big number. 2 raised to the 16th power is equal to 65,536. Once again, the same question applies. 65,000 what? Well, the answer is levels of tone. The answer is not different colors. It's levels of tone. You need to remember that, levels of tone. And I can describe what that means in a sort of a fanciful way. Excuse my artwork. I would like you to imagine that this is a house. It's a 2-story house with a ground floor and an upper floor. Separating those 2 floors are stairs. How many steps? 256 steps. I'm not going to draw them all out. I don't have the patience for that. I'm not that much of an artist. Oops. Okay. 256 steps. Now, I want you to use a little bit of your imagination. The bottom here is totally dark. The lights are out down here. You can't see. Up here is total brightness. All the lights are turned on. And you are down here and you go walking up the steps. And every time you go up a step, you pick up a level of tone, and it gets brighter and brighter and brighter and brighter. But at any one time, you are standing on one of the steps. You can't be on 2 steps, not at one time. What does it mean to have 65,536 levels of tone? Well, let's build a new set of stairs, why don't we? This one is going to be incredibly tiny. Every step is like a 16th of an inch. It's so tiny. So tiny. Think of how long it would take to build a set of stairs with 65,536 steps. Okay, I've run out of patience. I can't do that anymore. Okay, now, same thing. It's totally dark here on the bottom, totally bright up here, and there's 65,000 levels of tone. So as you go up these stairs, it gets brighter and brighter and brighter and brighter. But as you walk up, you can only be at one place at a time. This is what is called digitizing information. The fancy term here is called quantizing. In the old days, think of, I had a grandparent. I had a grandfather that was really into photography. And he lived in an age where there was no digital photography. And so for him, his set of stairs is perfectly flat and smooth. Imagine a slide, like a piece of plywood here at an angle, And as you go up, you can just smoothly, there's no break, there's no stairs that you stand on at any one time. There's a smooth transition from the dark state up here to the totally bright state. Okay? So as you're going up or going down and I say, stop, where are you? Well, you just sort of guess. Well, I'm 2/3 of the way up. Okay? You can't digitize that information. Whereas up here, I can ask you, how far up are you? Oh, I'm 32,619. How far are you up here? Oh, I'm at level 12. By the way, if you're at level 12 or at level 13, you're either one or the other. You can't be at level 12 and a half. Okay, these are whole numbers. All you have are 256 choices. All you have here are 65,000 choices. In the old analog days, well, it's a free-for-all. You can be anywhere that you want, okay? Some people like digital better. Well, you can kind of be more accurate, maybe, okay? But now I need lots of zeros and ones to record where I am in terms of levels of tone. Okay, so that's the background. Now let's move into our software. So what are levels of tone when we have an image? Well, let's start with something real simple. That picture of me holding a tomato, let's start with it in grayscale. A grayscale image has data that's in one channel only. Let's zoom in on this, and let's use our eyedropper, and let's get info. And I want to show you a trick. Right here is where we can tell Photoshop to make a distinction between showing me values in 16 bits and showing me values in 8 bits. So what I want to do here is go 16 bits because this is a 16-bit image. I'm going to go to the area deep in the shadows right here, and I'm going to make tiny movements. Now, look at that value, 944. I'm just moving just a tiny bit. That value is changing. And when I stop, do you remember my analogy of the house and the stairs going up? We're on the 16-bit side, up to 65,000 different levels, and we're on step 983. And I'm just going to move around just a little bit, very, very tiny movements, and we see those values change. What that means is my camera did indeed record differences in light and recorded differences of levels of tone inside of this file that Photoshop is showing us as we move around. Now, of course, we don't spend a lot of time with grayscale images. Let's move around to a color image. And we'll start here with my tomato at 16 bits. This is what the camera recorded. I have not done any color editing. This is raw data, unaltered from the camera. So I'm going to zoom in. And what I want to show you is a trick. You're probably already familiar with this. Hold on the Control key and strike Control 3, Control 4, Control 5. What we're seeing here are 3 independent channels of data. And every pixel inside this image really has 3 bits of data recorded. One for red, Control 3, one for green, Control 4, and one for blue, Control 5. RGB, red, green, and blue, that mimics the way that our color visual system works to a large degree. To get back to the color composite, I'm going to do a Control 2. As I move around now in this dark shadow, you'll notice that, hey, there are areas. I don't have any green or blue light recorded here, but as I move out, a little bit will start to be picked up. And as I move around very little bit, you'll see values change in the red, green, and blue. Of course, over here in the tomato, I have a ton of red light reflected from the tomato and then was picked up by my camera sensor. Notice that the red is substantially higher than the green or the blue. What I want to do is peel off a copy and convert it to 8 bits, and then look at the differences between. The way that you make a copy is you go image duplicate. I'm going to change the name to 8. When I click on OK, I will have two versions that are exactly the same. I'm going to take this version here and go image mode 8 bits. That's how you convert a 16-bit image to an 8-bit image. These two images at this time look exactly the same and will be indistinguishable from each other. So I'm going to zoom in that level on the 8, the same level on the 16. I want you to imagine that you're sitting right here in the same room with me, and we're both leaning into the image and we're looking at it with discrimination. We're looking critically at the differences between the 16-bit and the 8-bit. I might zoom in a couple times on the 16 and do the same thing here on the 8-bit version and switch between them and ask you, do you see any difference in these two images? And you would conclude correctly at this time, since we really haven't done anything with this image, that the 16-bit image and the 8-bit image look exactly the same. In fact, if we were to take these images and have them printed by your professional workflow, take them as is and print them and lay them side by side in a good viewing arrangement and view them with discrimination, take your time and evaluate any differences, you would say they are absolutely identical in every way. So it makes me come up with a conclusion that I want to draw. Well, there's no benefit to having the 16-bit version around. The 16-bit version takes up more disk space. I need a computer with more memory, with more processing power in order to deal with that 16-bit version. In fact, right now, there's no point for me having a 16-bit version around. At one point, though, would it make sense? And that brings up the topic of color editing. So what are color editing commands? Well, we see them in Photoshop as levels, Control L to bring that up, or curves, Control M, hue and saturation, Control U, and color balance, Control B. Those are the big four. Yes, there are others that are not as commonly used. And why would we, as pre-press professionals, ever be called upon to do this? Well, perhaps we've gone through a proofing cycle with a customer, and the customer says, I don't like the sky in this picture. Can you fix that for me? Can you make it a little bit bluer? What I want to do with this is start with a 16-bit version, and let's go image size, and we see that at 300 dpi, we have a 6,000 by 4,000. You take those numbers, you divide that by 300, and you have 20 by 13 and a third. Now, let's do canvas size. Watch what I want to do. I want all my modification to be pushed down, so to speak, and change that to inches. And instead of 13 inches, I want to add a little bit more on the bottom, 15 inches. And notice that I have this white part here that has opened up. I'm going to use my marquee tool and draw a marquee all the way across the bottom there. D for default, G for building a gradient. And I'm going to start here near the end. I don't go all the way to the end. I just come a little bit off of there, draw a line, and I don't go all the way to the end. I go almost to the end and let go, and now I have a really nice gradient drawn across the screen. And Control D to take away that selection, and go back to my M, and I'm going to build a selection, but watch what I do. I selected half of the gradient because we're going to make 3 very small or conservative color changes to this image, and I want us to see what impact does it have when we have this 16-bit version, and what impact will that have when we do the same thing on our 8-bit version. I'm going to make another 8-bit version. Click on OK. It's an exact duplicate. I'm going to go image mode 8. So now I have an 8-bit version and I've got a 16-bit version. We'll come back to the 8-bit version in just a minute. What I want to do is I want to simulate doing some color editing. I'm going to issue 3 commands, and they will be very conservative. They will be 3 small things. And I've decided that what this picture needs, first of all, is a change of levels. And as you know, we have our ends here and we have our end here. And I'm just going to change the 0 to a 5, and I'm going to change a 255 to a 250. So what I'm doing is I'm compressing. I'll click on OK. The next thing I'm going to do is a very small S curve with levels, and that increases contrast. So what I'm going to do is I'm going to very slightly raise the highlight end, and then I'm going to pull down the shadow end. But I'm going to make a note of the output and the input numbers. In fact, I'm really going to do this by typing in the number 194 and the number 183. Okay? Then I'm going to come down here to the shadow end, and I'm going to slightly pull that down. But I want to make sure that I do this exactly the same. So I'm going to say 64 goes to 72. Type in those values. Notice that this S-curve is very slight. I'll click on OK. And then I've decided that we have a problem with color balance, and our problem is in the shadow end. And the problem here is, I think, in my opinion, that the shadow end is just a little bit too blue. So I'm going to pull this towards the yellow, and I want that to be a -6, very slight. 3 very slight changes. I'll click on OK. And now I'm going to do a Control D. And I'd like your attention to be drawn down to the bottom of this. In fact, let's zoom in and let's look at the bottom. Remember, we made a selection, so this bottom strip down here was unchanged, and the top strip up here was changed along with the image. Let's leave that, go to the 8-bit version, okay? And I'm going to do exactly the same. So with my marquee tool, I'm going to start at the top. I'm going to select down, but only half of the gradient, right there. And I'm now going to issue those 3 exactly the same commands. That's why I wrote them down. I'm going to do my levels. I'm going to change that to 5. I'm going to change this to 250, a very slight compression. Next, I'm going to bring up my curves, and I'm going to put in a very slight S curve. But I want to be fair, so I wrote down these numbers of 194 to 183. Okay, and then down here on the shadow, I pull that down, and I want to go 64 to 72. I want that to be exactly the same curve as before. Click on OK. And the third thing I did was a very slight change of color balance in the shadow end, and I brought that to a -6 right there. Click on OK. Control D to unselect and then zoom in. Okay. So what I want to do on both the 8-bit version and on the 16-bit version is to take a look at the bottom there. Remember, the top part is the part I changed. The part on the bottom is the part that I didn't change. I'll zoom in a little bit more. What I'm going to do is 2 types of analysis. I believe that when we do high-quality printing, it should be evaluated, and we should be thinking in objective terms of science and math and measurement. We should be thinking in terms of subjective terms. How does it look? Is it acceptable to us? Will our customer be happy with it? How do we feel when we look at it? Those are all subjective things. And I want to do a quick objective and subjective analysis. So subjectively, when I zoom in on this, and I'm now looking at the 16-bit version, I'll switch to the 8-bit version, and I want to look at this, this graduated part right up here. The 8-bit version has the beginnings of banding. And this is a very, very important point. Whatever damage that you start to see here in the gray section, that's up above, is also happening to the image above. So whatever damage that we're doing and we are seeing in the gray is also happening in the color above. The 16-bit version does not have as much damage. Now, how do we look at this more objectively? We use the M for marquee, and I'm going to make a selection. I'm not going to select total black over to total white. And let's take a look at our histogram. And I want my histogram to be luminosity. This means recalculate. I want you to look very closely at, is this smooth? No, it's not perfectly smooth. Okay. This is a 16-bit version. We see tiny, tiny little marks there. All right. Let's go to the 8-bit version. I want to do the same. Zoom out. I want to make a selection that is very similar. There we go. And I want to view with luminosity. I want to recalculate. I'd like you to look at the difference between this and the difference between this and this. Do you remember somewhat at the beginning of this video that I used the term quantizing? Now's the time for me to define my terminology. In the old-fashioned days, when all we had was analog, we had smooth transitions from levels of tone from dark to light. I used the analogy of stairs being smooth going down. Well, in this new world where we're digitizing everything, levels of tone now have to be discrete. And the taking of smooth information and converting it into digital information involves quantizing. That means we're looking at that information and we're dividing it into groups. When we deal with 16-bit data, we do color editing, we're starting to introduce quantizing errors. The errors in the 16-bit is very, very small. They are there, but they're very tiny. The quantizing errors over here in the 16-bit version are pronounced. And what that means for us in the world of prepress is as follows. If we have 8-bit data and either the customer or we make big changes in color, we will be introducing quantizing errors. And if there are substantial quantizing errors, we will start to see defects when the piece is printed. We'll start to see things like banding, things that just don't look right, that are hard to understand. Where did that come from? If we have 16-bit data to begin with, which is easy to do, by the way, if you can control the photography, you can tell your camera to be in camera raw, which is capturing up to 16 bits of information, and you will have the benefit of being able to do color editing by having minimal quantizing effects. What that means for you, if you can get your hands on the 16-bit version, is you can make substantially larger color corrections to an image and not suffer the ill effects of things like banding and weird things starting to happen when you print it. So that's what the difference between 8 bits and 16 bits is. It's not so much when it starts, it's when you have to do color editing. And if that gets into the picture, well, you'll start to have problems if all you have are 8 bits. Now, all the JPEGs are all 8 bits. So what that means is we have to be gentle in our editing. We either don't do any editing, or if we are involved in color editing, we have to make small changes, not big ones. So that about wraps it up. It's important for us to know the difference between 8-bit data and 16-bit data. And I would highly suggest that you, as a prepress professional, spend a few minutes in Photoshop and do what I've done. Get your hands on some 16-bit data and go through the exercises as I have done. And use that little trick of opening up the bottom and making a gradation from black to white. And do some of these color changes that we've been doing so that you can see the effects of quantizing errors for yourself.